So the first video for chapter 14 was going over Venn diagram problems. So we're going to move on to the table type problems. They function just the same way for most, anyway, we have roughly 1,500 respondents. They answered the question as far as what level of education that they had, and we have 5 countries total. Total. If we select someone at random from this survey, so again, from the survey is the important part. Because that means that we're going to be worried about this table total down there of 7690. So we want the probability of selecting someone from the U.S. Again, you writing out things in probability notation, not a big deal. It's in our format. My AP Stats kids, they have to. So anyway, move on. Anyway, we know because we're taking from the entire total, I know my table total is going to be 7690, and I'm going to start there. I want to know what's the probability they were from the U.S., which is going to be that number right there, which is 1557. Okay, and it wants to have a decimal answer. I don't remember what you round to, so you're going to see me always round to 4 places. Anyway, as the what is the probability that person completed his or her education before college? So again. We are talking about a before college because this is a table, obviously, from everyone surveyed. So my table total, again, is going to be my bottom number. And we want before college. So before college is going to be high school or less, and then no answer. We're going to work with these 2 numbers down here. We're going to take 4195 and 1161. So if we do that, we're going to get 6965. What is the probability that a person is from France is the part that the person, okay, is from France or did some postgraduate work. Okay, so when we do that, France or postgraduate, we have to remember what groups that we're pulling from here. Again, this is the person, so we're talking about 7690 again, but we have different things that we have to do on top. We have from France, if we look over there, from France we have 1539. Doing postgrad, so here's France at 1539. Doing postgrad is going to be this column here, which is going to be 379. However, what we have to take into account here is that this 69 right there got double counted because it got counted on the row and the column. So that means I have to subtract away that 69 that got double counted. And we have to just pay attention to that as we do these. And what's the probability of France and finished primary school or less? France and primary. So again, 7690 because we talked about a person. And we just have to go over there and look. I need to grab an eraser so I can clear out these markings. And then we're going to look primary or less. Oh, there's primary or less. And then France. So that means we're looking at exactly that 309 right there. And that's all we're doing is this 309. And that's going to be 0402. Okay, so the next part of these also use the same chart, except more than likely we're going to have a condition. So as we read through this, if we select a person at random, what's the probability we chose a person from the United States who has done postgraduate work? Okay, so it's United States and postgraduate work. Again, a respondent at random. So that means that we're still doing 7690. I thought we were moving on, so there was my confusion and my pause. If we go up to that table, if we're looking for USA and postgrad, so there's the 84 that we're talking about right there. So this is 84 out of 7690, and we're going to roll in at 0109. Among the respondents who have done okay, so here we go. Among the respondents who have done postgraduate study. So this is our first one that where it is a conditional probability. Among the respondents who have done postgraduate study. So this is a conditional probability. The condition is they have done postgrad. What is the probability a person is from the United States? U.S. Okay. Now that's using the notation, and maybe I should just stop because it's probably pointless. But if it helps us figure out what we need, it helps us figure out what we need. Now with a column, this is our first one, is our first conditional probability that had a table to it. We know they have done a postgraduate study. So that means that I am only looking at this column here. So my denominator becomes 379 because I'm only looking at individuals that did postgraduate study. What portion of them came from the US? 84 of them did. So that means we're going to go 84 out of 379. Okay, and that's 2116. Again, if we were doing that, we would need US and postgrad divided by postgrad, okay, is really what we're doing when we do that, okay. What is the probability that a respondent from the United States, all right? So again, if we highlight the respondent from the United States, so I know that when I do this, I am only interested in having and looking at the United States. So I'm going to come up here, I am going to erase this circle, and we're going to be talking about only the respondents from the United States. So I'm looking at this here, this row. I don't know if it'll do that for me or not. Look at that. Cut it off though. Okay, no bueno. Made it worse. There it is. So 1557 is going to be my denominator. Okay. My numerator then becomes however many we're doing postgrad, and that was 84. So 84 out of 1557 is 0539. What is the probability that a person from China, that a respondent from China, so I'm only worried about respondents from China, so that means my denominator is only going to be from the China row, and that is 1502. And they only have a primary level education, so primary 506. So that would be a 3369. And lastly, what's the probability of the respondent with only a primary level education? So a respondent with only a primary level education is from China. So they sounded very, very similar, but we're going to flip our denominators, okay? Because now we're only worried about primary. And if I come up here, primary is 1161. So my denominator is going to be 1161. And I scrolled through there too fast, but the ones that were from China are 506. So that means that we're going to roll with a 4358. Okay. All right. Moving on to, you draw a card from a deck of 52 cards, find each of the following conditional probabilities. Excuse me. All right, the card, now sometimes this is almost easier with logic than it is writing something down, but we'll do a combination of both, I guess. Interesting. Oh, I changed it. Okay. Sorry, I was looking at my notes versus looking at this, and they're different, so that's where my pause is coming from. You draw a card at random from a standard deck of 52 cards. Find each of the following conditional probabilities. It's a heart, given that it's red. Okay, so if we don't know anything about hearts, there are 4 suits. There are clubs. There are spades. Each of these being black in color. There are diamonds. And there are hearts. Each of these being red in color. There are 13 clubs, 13 spades, 13 diamonds, and 13 hearts for a grand total of 52 cards. Okay, so given that the card is red, okay, So I'm only worried about red cards. So how many red cards are there? So the condition, and we'll write this out. Given it is red, what is the likelihood that it is a heart? Okay, so we really only have to worry about how many red cards are there. Well, there's 26 red cards. How many of those are hearts? 13 of them are hearts, so that means this is going to be a 0.5. We're going to flip that around. The card is red, given that it's a heart. So again, given that it's a heart is the condition. The condition is it is a heart. What's the likelihood that it's red? Now let's think about this logically. I have a heart in my hand. What is the likelihood that it is red? Well, it's a 100% chance, but here we go. Out of the hearts, okay, again, there are 13 hearts. So that's the only one I'm worried about, 13 hearts. Of those hearts, how many of them are red? Well, all of them would be red. So that's where we get 100%. Okay? The card is an ace, given that it is red. Okay? Again, think about this logically. Given that you have a red card, well, how many red cards are there in the hand? Well, there's 26. Okay? So I know I'm going to have 26 as my denominator. And again, we'll write this out. So the card is an ace, given that it is red. So I know that it's a red card. So that means we're going to have red on the bottom. We're going to have aces and red in my numerator. Okay, so how many red aces are there? The ace of diamonds and the ace of hearts. And then how many red cards are there? 26. And this is one that I don't have, but I'm going to have to grab my calculator because I don't have this one in my notes. But we're going to take 2 divided by 26. And we're going to get 0769. The card is a queen, given that it is a face card. Again, we'll write these out. We know that we have a face card. What is the likelihood that it is a queen? So again, given that it is a face card. So I have a face card in my hand. What is the likelihood that it is a queen? Is how I can think about that. So I need queen and face card divided by face cards. So I know, and I didn't get into that, there is a jack, a queen, and a king of each of their 3 suits. So 4 times 3 is 12. There are 12 face cards. There are the 4, each one of those 4 individual ones. So that means that we're going to be doing 1, 3 or 0.333 repeating. And there is going to be my probability of a queen, given this face card. You're dealt a hand of 3 cards, one at a time. Find the probability of the following. So this is going to be a little bit different yet. This is slot probability again. We are dealt 3 cards. However, when we dealt with slot probability last time, they were all independent events because my probability did not change. And that's what different is. That's what's different now, as these probabilities are going to change. The first heart is the 3rd card that's dealt. So this one's going to be a heart, but this one's going to be a not heart, and this one's going to be a not heart. So I know that there are 26 not hearts in a deck of cards out of the 52. But I'm going to pull out a non-heart, so now I only have 25 non-hearts, and there's 51 in the deck. So now I'm going to slide over to hearts, and I know that there's 26 red cards. Hearts, sorry. I'll read what's there. Hearts, there's 13, but there's only 50 cards left because I've already removed 2. And then it's learning how to use your calculator to get all that into your calculator. It's 1453. Okay? Again, 3 cards. All are red. So I need a red, followed by a red, followed by a red. And again, 26, 13 in each suit of hearts and diamonds. So 26 out of 52, but then that's going to reduce down to 25 because 1 has been removed. And then it's going to reduce down to 24 because 2 have been removed. And that goes for both of them dropping by the same amount. So that is going to be a 1176. No spades. So again, it depends on how you want to do this. We can do 52, 51, and 50. We can get those put in place. No spades. Well, that means it has to be a club, a diamond, or a heart. So that means we have 3 times 13. So that means that we have 39, 38, and 37. We multiply all those together. So this is all cramming together a little bit, but it's 0.4135. And lastly, at least 1 ace. And again, at least 1, we change into 1 minus the probability of no aces. So this is going to be 1 minus. We got to have no aces, but last time I could just take something to the third power because it was independent. My probability didn't change, but now it does. So there are 48 non-aces because there's 52 total and 4 aces. So that's why 48, and then 47 out of 51, and then 46 out of 50. And that's going to give me my probability of no aces. So we got 0.2174. If you draw a card at random from a well-shuffled deck, is getting an ace independent of suit. Okay? So, meaning is getting an ace independent, we'll say ace independent of a club. Okay? So what we'll do is this. We're going to find out what is the likelihood of drawing an ace, and we're going to compare that to the probability of drawing an ace given that you've already drawn a club. So in our deck of cards, there are 4 aces, and there's 52 total cards. And I can't read that that's quite 52, so we'll try again. There's 52 cards. Now I know in this conditional probability, now I only have club in my. I know I have a club in my hand. What's the likelihood that it's an ace? Well, there's only 1 ace of clubs, and it turns out that these are the same because the 4/52 reduces down to 1/13, so they are independent. Okay. How far am I going? We're gonna get to we're gonna get through some more. The probability that an adult American man has high blood pressure and/or high cholesterol is shown in the table. What's the likelihood that the man has both disabilities? Okay, so we want high blood pressure and high cholesterol. So we want high and high, so really that's just a number on the table. That's going to be 0.11. Okay, high blood pressure. So here's blood pressure, and here is high. So we're going to add those together, and so it's going to be 0.27. A man with high blood pressure. So this is a conditional probability. They have high blood pressure. What's the likelihood they have high cholesterol to go with it? So again, this is depending on how you want to look at this and how you want to roll with it, if you want statements, but logically it goes like this. High blood pressure. So I know I'm only worried about that particular column. We already did its total. Its total was 27. Okay? And out of that 27, which of them has high cholesterol? Well, the 11% does. So this 11 out of 27 are our last 2 answers. Okay, so that turns into 4074. And lastly, a man has high blood pressure if it's known he has high cholesterol. Again, a conditional probability. It says if it's known he has high cholesterol. So he has high cholesterol. What is the likelihood that he has high blood pressure to go with it? Okay, so if we erase things off of here to clean it up. Okay, we know the man has high cholesterol. So high cholesterol, high. So I know it's this row here. Now, we don't have a total over there, but that total would be 32 if I had that total written out. Okay? So, 32 is going to be my denominator. And then which ones have high cholesterol to go with that? There's that 11 sitting there again. So this is going to be 34, 38. Given the table properties from exercise 9, again, this was actually supposed to be up here, unfortunately. So we're going to cram this here in the gap. It doesn't work out very nice. And so we are going to end up with, are they independent? So I am going to take a previously calculated, I have the probability of high blood pressure right here. Okay? And I have high blood pressure given high cholesterol there, so I'm just going to steal those two. I'm going to compare the probability of high blood pressure, and I'm going to see if that's equal to the probability of high blood pressure given that we have high cholesterol. Okay, so maybe I'm doing a disservice and not writing out all the notation on that, but we'll live with it. Okay, so high blood pressure up there in problem B is 27. High blood pressure, given they have high cholesterol, is down here in problem D. That's 34, 38. So we can see those probabilities don't match. So the likelihood of high blood pressure goes up if it's known we have high cholesterol. So therefore, they are not independent. High blood pressure goes up with high cholesterol. Okay. 2 more, and then I'll shut this video down. A junk box in your room contains a dozen batteries, 5 of which are totally dead. You start picking batteries and testing them and find the probability of each outcome. So the first 2 you choose are both good. So again, it's just slot probability. We have to fill the slots. Now I know that my probability is going to change each time. So 5 of dead, that means that 7 are good. So 7 of the 12 are good. And on the next draw, 6 out of 11 are going to be good. So we're just going to multiply those 2 together, and that's going to give me then a chance of 0.318. At least one of the first 3 works. So again, at least we're going to go with at least 1. We always morph into 1 minus a probability that none work. So when we do this, we're going to do 1 minus the probability that none work. Now the problem is there's 3 chances there because the first battery to not work is 5 12s. The second battery to not work is 4 11s. And the third battery to not work is going to be 3 out of 10. So I have to be able to get that into my calculator, and it's 955. The first 4 all work. And if that was true, then we probably should go buy a lottery ticket. But anyway, there's our first 4. They work. So 7 out of 12, but then it's going to be 6 out of 11, and then 5 out of 10, and then 4 out of 9. Okay? And we have to multiply all that together, and we're going to get 0707. So the slide's possible, but not very often. And lastly, we have to pick 5 batteries before we find one that works. So that means it's going to be bad, 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 and then finally good. So bad, 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 and then a good battery. We had to pick 5 to find one that works. So that means the first one was bad, so that's 5 out of 12. And the next one was bad, 4 out of 11. The next one was bad, 3 out of 10. And the next one was bad, 2 out of 9. But that last one, it was good because it was 5 out of 8. Okay? Very high probability. And I'm wrong there. That's not 5 out of 8. There were 7 good batteries there, so actually we're talking about 7 out of 8. Okay? Again, that's a small chance that that's going to happen. All right, and our last one here. In the 2018 poll conducted by the University of Montana, classified respondents by sex and political party as shown, is party affiliation independent of respondents. So again, we're going to have a test for independency. Okay, so we just have to think through something. I don't know what I don't have any nice upfront probabilities, so I'm just going to pick one and go with it. So I know my first outcome is being Democrat, so I'm just going to pick the probability of Democrat. I'm going to compare that to the probability of being Democrat given that I could be either one of those 2 genders, male or female. Just because I'm trying to match up with my notes and that's less calculations I have to do, I'm going to choose a female. Okay, so the likelihood of being a Democrat. So if we look at this isn't very nice to us because we don't have any totals, so I'm going to write these in here. There's 105 males, and there's 97 females, so that means that there is 202 individuals in our table, 84 of which are Democrats, and 78 which are Republicans, and then 40 are listed as independent. Okay, so again, if we look at this Democrat, okay, I know that there's 84 Democrats out of 202 people. So if I did that decimal is going to give us 4158. Now this one's going to be, the next one over here, that's going to be a conditional probability. It's female, so I'm only worried about the female row. It's 97. Of those, 48 are Democrats. So if I figure out that probability, that's going to be 4948. And so therefore they are not independent. The probability of being Democrat increases by being female. Okay, I'm going to shut this video down and then we'll